provide a good conceptual model? First of all, you have to understand the conceptual model. You have to understand the conceptual model. Conceptual model does not mean conceptual model of your understanding. Conceptual model means you have to understand the user conceptual model. First of all, before knowing the conceptual model, first of all, you have to understand the user. That's why in the previous chapters, in the previous chapter, I've explained how what are the different personality traits of the user. Then we study how the human process the information, how we gonna improve the information, how we gonna map or recognize the information, how when we see some visual object or slide or some screen or some image, how we are perceiving that thing, how we are mapping that thing. For example, remember those Gestalt laws, Gestalt laws, uh, which shows the laws of proximity, law of similarity, law of closure, law of symmetry. There are different types of laws are there which which shows some relation between some visual object and in your mind. So you have to be properly uh, know the conceptual model. If a conceptual model is clear to you, regarding that product, it must be quickly designed. That software must be quickly designed, and then must be quickly developed. So if you have a not poor conceptual model, it must not be designed according to the user perspective. So knowing the user conceptual model, what user is thinking, how the user is feeling about the product, how the user is feeling, that how he or she gonna interact or access those feature, and how the system will respond. Is it understandable? This is called as conceptual model. So conceptual model is very important. So when you are designing any product and designing any layout, so conceptual model is getting the user conceptual model is the primary task of your team, of your design team, to know what user is feeling. So making visible means that properly mapped according to what features you have shown, what actions you have uh, shown on that system, and respond according to response of that action being invoked by the user. It must be sensible, it must be meaningful. For example, if user are using those features, the system must provide response and must shown the response in a positive way, in a sensible way, in an understandable way. If user is using those feature and the system does not shows any action or any response, any sign, so it is not properly mapped. It is not you can say feedback is not been good. So visible affordance is there, mapping properly, natural mapping is there, must be constraint shown, the product must shown some constraint, uh, and cultural idioms must be followed. And so the last point is very important in design, and remind person of what can be done and how to do it. So he or she must, while using or accessing or while thinking about the product, he must feel that this feature gonna be mapped with this feature, this feature can do this thing. uh, Thinking rather than doing, or you can say that in advance, doing rather than thinking. So remind person of what can be done and how to do it. If only just while accessing some product, if your user is just exploring or just analyzing that how it's going to be done and not actually doing it, so this also be a lacking factor in your design. If your user is controlling the product, if the user is doing all the features, the designing principle is being mapped. This designing principle is that user is in control. This feature is called as internal locus of control. We're gonna study in some different topics what are the some design or interface guidelines while you are designing a product. What principle must be followed in a good interface design when you are designing the interface, the layouts of an application. One feature, designing feature, is internal locus of control, meant that the user is in control, the user is in command. For example, while you are navigating with your smartphones and gadgets, the user is feeling that he or she is in control of that thing. Uh, the smartphones provider or the company of that smartphones giving all the features access to the user that he can or she can easily change, for example, the look and feel, the icons, and the program short listing, the accessibility, the themes, the layouts. What we are thinking, we can easily do that thing. So if we are providing those features to the user, that the user feel is in control, the user feel I'm in command of that thing. For example, in gaming, in high-tech games, in 3D games, in virtual reality based games, if the controls and the features being provided to the user are properly mapped and well synced together, if the environment is there, the user is in command, the user feels ownership towards that product. So uh, for having a good design, you must follow those principles. It must be naturally mapped. It must have some constraint, visible constraint. So that's why visible constraint means by looking at the product, tangible or intangible. If it is intangible, the constraints have not been there. But yes, their technology constraints are there. Yes, there are some limitation according to the time limitation is there. There's some tools limitation is there. So the limitation must be there. You must know some limitation also. Okay, looking at this design, what you feel? These are some person moving from men's washroom. If a person have some extraordinary height, yes, if there's exceptional cases, it must he or she must bang his head. So the door size must be properly uh, according to that height. One can easily move. So this shows a little bit example, a little bit teaser, a little bit flavor of a bad design. So so you must know uh, the culture. What are you going to do according to that thing? So there are some different bad design examples. Websites are there, interface hall of shames, or a different interface hall of shames. Some bad map design, some poorly bad products, or some different websites also examples are there. Some bad design examples are there, which are not properly mapped, which are not properly mapping those five factors. So this is there, and this is it. So next, by looking at this object, definitely what you feel, you can feel that there's umbrella and there it's an excellent product. Whosoever has designed, whosoever think that the wind and the rain is coming towards different angles. Yes, we have seen in our city. You must have enjoyed this rain day before yesterday. It was awesome weather. So if that happens, so the umbrella does not work in that scenario. So how intelligently, how tactfully this umbrella has been designed, and this sheet has been put put together. You can see the knobs, you can see the pins attached towards umbrella, and it's been covered properly, and one can easily move towards the next side, towards any activity you should moving. Look at how intelligently the components, how intelligently the components have been mapped, how intelligently have been designed. The person has been eating noodles, and definitely uh, there's very hot. So a fan with attached with the battery is also attached with this chopsticks, and it will give a warm effect too, and soothing effect from the fan too. So the things can be put together in a decent way and can be used in a usable way. So look at this slide. So it is not you, it is not a gum stick, but yes, it is a gum stick. But once it is been uh, finished, you can use for butter stick, and you can print out the butter stick and put the butter in this thing and put this tube in this in the refrigerator. It will freeze it out, and this can be used for this purpose. So it can be used in this way, in an effective way. So one could use in this way. So we have different models of interaction, and the best one is we're gonna skip this models of interaction because the important thing is normal models. I'm just skipping this. It's not been covered in your course also. Model is definitely under abstraction of reality, uh, like this process model. This is an important dollar normal model. I'm just explaining those stages. For example, software process models are also being followed for by software engineers for developing any product. So in this HCI professionals, some models following some process model. There are different models are there. There are different approaches are there. For example, task-centered design, user-centered design. We're going to study simple definition, but um I'm not going to explain all those models and characteristics in detail. For example, the most important model is dollar normals, and you can say normal dollars. Um so this is the important researcher in HCI. He presented this seven-stage model. This is seven-stage model called as normal Donald model, called as execution evaluation cycle model. Okay, first three steps are considered to be for executing, and last three for evaluation. User establish the user goal. The second stage is formulate some intention how to do it that thing, and third stage is specify action at the interface, what action we're going to perform at the interface. Fourth is execute that feature, execute that action. Fifth is perceive system state, just like that in a test case, expected result or actual result. You must know the test case format at the end. Perceive system state, that what the system, how the system gonna be responsive. Interpret system state, that after that feature, what is the condition, what is the system state. You're gonna map, or you're gonna write and map, perceive and interprets are equivalent or not. Evaluate system state with respect to the goal. For example, take an example of login. You establish the goal that first establish the goal that we're gonna log into the system. Formulates intention. Formulates intentions mean how we gonna access that login in that software. For example, we must put as user ID, and then we must put user password in that features. This is the intention, and the user comes in, put his user ID and user password. If the user can log in some another way, we gonna also do it. It's just like some use case, but in a different way, in a different model approach. Specify action at the interface. For example, user put his ID and password. You written those two intentions, those 2 points in formal intention. Second ending, third ending is specify action at the interface. You can click that thing, and or you can um, do an action if it has been told to do it. If the system has been told that do this thing, so if you put this information from the keyboard by entering that keyboard, on clicking that at the interface, it will execute. So you have to click that button, or you have to click that action for performing that action. So in the first step, execute action, you definitely execute that action by clicking, and specify action at the interface. You just by putting the keyboard, by writing from the keyboard. In fourth step, execute action by clicking that on the interface. A button is being shown by clicking that button. Then you're gonna log in. Perceive system state, if what you feel that after clicking that login, the system will show a welcome message, or system will show all the features. You must write these steps in perceived system state. Interpret system state, uh, while actually doing that task, if you're actually logging into that system, it means your perceive or interpret system states are same or equal. Evaluate system state with respect to the evaluate system state with respect to the goal. If you log in into the system, it means your goal has been fulfilled. So these are the 7 stages explained by the Donald-Norman's model, your Norman-Donald models, also called as execution and evaluation cycle. So it must focus on the user's view of the interface, the how the user feels, the how the user intention is by looking, by accessing that feature, what user perceive, what user feel that thing. So this is Norman Donald model. This 7 stage model is expressing in diagram way. You have to first of all start from the goal, then towards left side goal, and then it will execute and system will response and evaluation is been shown. So this is look at this thing. So just user establish the goal, then the third 3 steps are being focused on the executions, and the last uh, 3 are for the evaluation stage. So establish the goal, then the execution, how you can execute or establish. First you draw the goal. It's just like what we in a object oriented design, the use case, uh, the use case goals and description, and the main success scenario. So it's a little bit different, but the meaning is the same way concept. So this is execution evaluation. So it is also called as Gulf execution and Gulf evaluation. Gulf is the separate mental state for physical ones. Gulf execution means usual formation of action and action allowed by the system. And Gulf evaluation, user expected change, system state, action presentation of the state. Execution evaluation, it is also Norman Donald model, also called as Gulf of execution and Gulf of evaluation. How the user formulates uh, the goal, and how the user has some intention according to that product, according to that software. What are the intention you must write, and what are the action performed by the system to the user. And then evaluation means um, how the user is feeling, the system will respond, the system state, and how actually is been actually shown in that system. So it is clearly Gulf of execution, Gulf of evaluation. So there are different other models. I'm not explaining. I'm just skipping it out. A board and BL model, just user input, then system, then output. User is inputting uh, some input, and that input is being used by the system, and after processing that, system is showing some output to the user. So just different Gauss model, or were there goals, operators, methods, selection rules. So famous was Norman Donald model, and this Schneiderman, another model, has been presented by Schneiderman, object action interface model. So this model is being used for multimedia type of application, or for that type of application model, where the user has given a lot of flexibility, a lot of range of features being shown to the user, that he or she can access or invoke any object and perform any action on that object. So the task, for example, object action interface model, and first you have to select the task. For example, in a universe, you have to select some atom, then you have shown some actions on that object action. First is task, and then on interface. First, in a galaxy, you have to select different atoms, or what are the actions performed for selecting an atoms, and then on show some steps while you are using some interface. For example, if you are selecting an atom in a universe, if it means you have select some object and it shows some metaphor representation pixels and what are the action by selecting a different pixel on certain location, certain screens area, that action is being performed by the system or towards that. This is some different action interface models are there. So object action interface models are there. Some different interface models are there. So I'm not going towards into the looking at the different slides. So just the important thing in this interaction models are also there. Yes, GOMS model are there. Some object action interface model are there, but the famous one is the normal Donald model, Gulf of execution and Gulf of evaluation. Yeah, normal Donald models which some 7 stages, Gulf of execution and Gulf of evaluation. So the important diagram was there. Once you establish the goal, first point is also establish the goal. 7 stages, 7 points in that normal Donald model. First you establish the goal, then uh, you have different 3 steps in execution, and then you have 3 steps regarding towards evaluation. So that's why it is also called a Gulf execution and Gulf evaluation. So in this important chapter of interaction, what we have covered uh, 5 factors which are involved in a good design product. If a product has not properly mapped those factors, it would consider to be a bad design. So we have covered all the 5 factors one by one with examples. What are those? I'm going to just review at the end of this chapter. For example, first point is natural mapping and visual affordance. The order is not important, but the important thing is like visual affordance. Second is visible constraints. Then we have natural mapping, feedback, and conceptual model. Visual affordance means the appearance, the physical objects, what we are looking at that object, its appearance. One should feel that what it do, how we gonna do it, how it look like, what are the characteristics, what are the other features by looking at those. So visual affordance must be there. It is if a product is a bad design, so by looking at the widget one can't understand one if a person can't understand what is this thing, what are the features, how are we going to use these things, so that would consider be as a bad design. So there are different websites are all there. I've shown you the websites hall of shame baddesign.com. You can go towards those sites, just entering the URL. You can see different bad design examples. You can see different bad design systems are there, how it is not been properly showing some feedback. So you must know what if I'm going to give you some object, so you must clearly understand, you must clearly write also, is does visible constraint is there by looking at the object, does this system give some feedback, does it properly naturally map. What naturally map means, the features, the characteristics that product or the software is being showing is properly mapped or not. Remember the example of natural mapping of multimedia software or any editing tools, the palettes we have, the editing palette we have. If we click some palette and it is been embossed or it is been depressed, and if you have clicked and it's not shown, it is not been properly mapped. So if we have selected the brush button and its brush button is not been working, and the spray button has been working, so it is not been properly mapped. So it been naturally mapped according the controls and their effects. So that is why the look and feel of the Java is very important. The controls and their effects is being shown. The Java has some look and feel by default, 2 or 3 look and feel it have. When you have designed the graphical application, the menus, it has some different built-in look and feel, but you can design your own forms and layouts, and you can also design. So it must show some feedback, it must show some properly conceptually model. The user must understand it, user must respond according to the, if the user conceptual model is been properly followed, then the user will be satisfied, then the user will own that product. So at the end of that thing, we have seen some different interaction models in this slide. So this is around about the end of this interaction model, and interaction about different concepts we have studied in interaction in the later stages, in the later chapters. We're going to study next time ergonomics. Ergonomics is not a, uh, you can say, complex or lengthy. It is considered to be and few some slides. So in the next lecture, side by side ergonomics, we're gonna also uh, study interface style chapter also. So this is and about interaction models. I hope you must understand it, and if you've been given or providing some different examples of interaction, for example, given some website or given some physical object or shown some image, so you must know uh, whether the five factors are there or not. So it is not like that okay, uh, you're not perceiving it, but you have to properly think about it. Are those five factors? For example, take an example of uh, like what we have studied in this lecture. We have shown some teapot example, we have shown some bicycle, you have shown some we have shown some Caesar example, we have shown some different examples. So you have all you can see in your real world scenario, you can see in your home design appliances, these are these properly good design, are these following these five factors or not. For example, I just explained the split example. The visual affordance is there. Yes, visible constraint must be there. Visible constraint means the split is consisting of two parts. One is indoor unit and one is outdoor unit. So outdoor unit must be placed outdoor, must be placed outside. It not be placed inside. So in a funny video, in a funny picture, when a person buys some split and he complains to the customer support of that company that I've installed an application, I've installed that split which I have bought from you. Um, it's not been properly working. It's been providing heat. So when you saw that picture, the outdoor is being placed inside, the indoors, the thermostat level is being placed outside. So you must know the clear understanding of that. You must know the cultural idioms. You must know the usage of this, how to install that thing. So that's why if it is not been properly installed by you or by the company, so it will not work properly. So uh, it has been, yes, visible constraints are there, uh, and then that system split is providing feedback. Once you change the thermostat level, once you change the different features, warm and cold, it will give you feedback. If it has not been giving you some feedback or status, so that would be not conveniable, that would be not understandable, that would be not um, understandable to the user. While you are testing that split in a custom sports center, in a display center, you all been familiar with those features or system, or you're going to test in those shops or in those outlets. Then you go for bio shopping. So it is properly nationally mapped, and nowadays you can access split AC through IoT. You can access this is also a new project. You can access those accessories from IoT. You can access the AC features and the billing also from your app. So this would be a good project in your final project line. So that could be a good handy project. So feedback is there and properly conceptual model. So conceptual model is also there. So in any product, these five factors must be followed. So I'm going to end this lecture. This is a small lecture but consisting of very important concept of a design product fulfilling those five factors. If that factors are not being properly mapped or not been followed or not been there present in any design, so tangible product or intangible, so it must be there. So it would be considered, if it is not being followed, it would consider as a bad design. So the design must not be considered as a bad design. It must be properly mapped. So it must be properly understandable. So must we have seen different layouts and different features and different how those features are been actually implemented. I've given you one more example of a bad design or bad information is presented. For example, in a department, when you are coming towards the department, uh, when you're coming towards your department, your face would move towards, your face will be upfronted towards the wall side, and some visual uh, object you have seen that fire exit. I've already explained to you. It must be written and it is not in this way, that fire exit. It must be written that emergency exit way, and it must be pointing towards, arrow towards right side, and it must be written in a green way, in a positive way. So this is a message written error, that there is a way. Yes, there is a way. There is a shortcut way. There is a emergency exit way. But the way, the way it has been written, how the way it has been presenting, it's not understandable. It's not viable, feasible. You just know that you know the technological thing. The computer science knows the technological thing at the end of the degree, but they are lacking with the presentation skill. They are lacking with the planning skill. They are lacking with that how to present, how to behave. So this is a very important factor. You must know and learn the way of expressing yourself, the way of presenting yourself. For example, you will be presenting your proposals to different supervisors through Zoom or through different technology. The way you're gonna present your proposal, the way you're gonna present your idea is it must be very pleasant, must be very pleasant. You don't have to rush towards the different slides. For example, a guy has been moving towards different slides, and he's the other member is just holding its previous slides or moving towards next slide. So you must be properly well behaved, well synced, well properly mapped uh, how you are presenting. You just not rush towards your slides. So it's a way how you tackle your thing. It's a way how you presenting your information in a software. It's a way how you presenting your features. So you have to take guidelines from industry. You have to take guidelines from the example which we have shown. We have to take example from uh, the standards which been followed in industry. So so this is it. I hope this must be very informative in learning and adopting how the things are presented, how you are perceiving that thing, how you are expressing the features in your mind, how you are tackling with that thing. So it must be well interactive. Thank you. That's and the today's lecture. I'm generating this lecture. It will be available to you on LMS on your system, Moodle. It also been uploaded by OCR in my Google Drive link. Thanks all. It's I think it's a 76-minute lecture, and after a few minutes, I'm gonna available in a WhatsApp group. You can ask any query, you can ask any question, you can give your lecture response on your group, WhatsApp group. Thank you.